Yeah, welcome. So the objective of this lecture, e-lecture, is to make sure we clear the small topics that are remaining. Actually, that's only one topic, which is sequences. Okay. And I will do sequences here. And also there will be a few others like undersets and grids. The grids part, okay. Gaira has already done the full coverage. However, just the grids, just an introduction of that, and also some like a different approach to permutations and combinations. Okay. um, Akalanka did a wider coverage of this. Mine will not be that wide, but it's just a different approach. I learned this just because permutations and combinations are quite confusing, at least for me. I learned it from two different sources. So Akalanka did a wider coverage, whereas I am presenting some like the same approach, but in a very like a slightly different manner, right? And just some examples, okay? And so, as I said, the objective is to clear these things so that we go into the final lesson, which is class number 11 on 3rd of July, Sunday, Sri Lanka time, to do like on a full revision mode, okay? That's the objective. And yeah, so we will be covering these three things here. Okay. And while I'm doing this lecture, whenever an exercise is given, like a question number 1, question number 2, like that, you can pause the video and attempt and then come back to the video to see my answer. Okay. I won't be keeping gaps in the video just for your convenience of actually answering those questions. So you can just pause the video and come back. Okay. Yeah, let's begin with sequences. So sequences is what you learn for O levels as Samantara Shredi, Gunottara Shredi. Okay. But we are here only looking at the arithmetic sequences or progressions. Okay. There are geometric sequences, which we are not looking at in the GRE syllabus. Okay. So now, if you look at a sequence, for example, 7, 11, 15, 19, so and so. So this is a sequence, okay? So you have the first term, you can call it A1, second term, A2, third term, A3, so and so. So the common, like what binds this together is that common spacing or common difference, okay? 4, 4, and 4. So this is called the common difference, okay? And it's termed in terms of D. So if you look at this sequence, I would always encourage you to know where the equation comes from, so that in case if you have any doubts about that equation while you are in the exam mode, right, you can always derive, right, rather than guessing. Well, I don't remember. You don't have to do that kind of guessing. So now here, let's say A2 or the second term, okay? This is the second term or A2, which is 11. How do you obtain 11? That's 7 plus 1 times 4, right? 7 is A1. 1 is the actually n minus 1, because here n is 2, because this is the second term. And 4 is that common difference or the spacing. And similarly, if you look at A3, which is 15, how do you obtain that? 7 plus n minus 1, which is 2 times 4. So this is 8. So 7 plus 8 is 15. Okay. So from here, you can derive that the equation for the nth term, okay, this is the equation for the nth term of an arithmetic sequence. Okay, so that will be an is equal to a plus n minus 1 d. So how did we derive that? We just saw how that's going in the example. Okay, so here, this is the nth term. This is the first term. Okay, sometimes you can, rather than calling it a, you can even call it a1. N stands for the number of terms, and d is the common spacing or common difference. Okay, this is the first equation that we are looking at. Now let's do a simple example based on this. So question 1, what is the 10th term in the above sequence? Okay, so how do you look at the 10? How do you find the 10th term? A10, that is the 10th term, is equal to the first term A1 plus n minus 1, means 9, times the spacing. Okay, so it's like the first one, you know that, 1, 2, 3. So the first one plus the common difference times the number of terms that follow the first term, n minus 1, is equal to that last term. So here, excuse me, A1 is 7 again, plus 9 times 4. This is 36. 36 plus 7 is 43. Okay. So that's the first equation. Now, the second equation, that also you don't need to memorize. Okay. Don't memorize this. Don't memorize any of the equations here. Now, if you look at this sequence that we were taking as an example, okay, 15, 19, 23, 27, so and so. Now, any sequence, okay, it can be something like really simple, like 1, 2, 3, 4, 5, and 6, right? Look at the addition of the first one and the last number. First number and the last number is 34, right? And it's the same with the rest. See, second number and the second last number, third number and the third last number. And similarly here, they all account for 7 as well. Look, this and this, 7, this and this is 7, and this and this is 7. Okay, so fundamentally, this is how we obtain the second equation. Okay, so the number of the sum of the number of terms, n number of terms, is equal to the first number, a, the first term, and the nth term. Okay, so there are 3 pairs for 6 numbers. Okay, so that's the half a number of pairs. So that multiplied by n divided by 2. Okay, you can write it in different ways, but this is how you remember. So the first one and the last one added, and there are half the number of pairs. That's the second equation. Okay. Let's also do an example on that. Like the same example, what's the sum of the first 10 numbers here? You previously found the n, like the 10th number. So that was 43. Okay, the first number is 7. And n is 10, right? So that will be 7 plus 43. 10 divided by 2 is 5. Okay, so that's actually 50 times 5, 250, right? So now to obtain the third equation, what we do is replace. Now the first equation is this, right? You remember we obtained that. The first equation was an is equal to a1 plus n minus 1 times d. Okay. Now, the third equation is that you replace this an with an from the first equation. Okay. And therefore you receive S, the sum of n numbers is equal to a1 plus a1 plus n minus 1 d. And that is within bracket. And then outside the bracket, you have n over 2. Therefore, Sn is equal to 2a1 or 2a plus n minus 1 times d multiplied by n over 2. That's your third equation. Okay. Third one. Yeah. So the idea is you don't have to memorize any of these. Okay. There's a way to obtain. I think many O-level teachers will teach you this way, but some people may not. Doesn't matter. Now you know how to do that. Okay. Now we will do some examples. Okay. I'll give you like starting from question 3, since we did 2 questions. So question 3 is find the sum of the first 15 terms of a sequence whose nth term is 4n plus 1. Okay. So here we are asked to find the sum of 15 terms. So we know that the straightforward equation is that either you could put A1 plus AN n over 2. Okay. This seems to be the reasonable equation because I mean, you don't really have to find the D or the common difference or common distance if you use this equation. Okay, so we are supposed to find the sum of the first 15. Okay, S15. So what is the idea of this? This means that you can take the each value for each n, right? So here also n is actually 15 in this case because you're looking at 15 terms. So A1 is 4n plus 1 means 4, 1 plus 1, and that is 5. Similarly, A15, the 15th term, which is the AN, the last one of the sequence, is 4 times 15 plus 1, that is 61. Therefore, SN, sorry, excuse me, S15 is equal to A1, which is 5, plus AN, which is 61, 15 over 2. And that's actually 66 times 15 over 2, that is 33 times 15, and that should be 330 plus 165. So the answer is 495. Okay. Yeah. And here we did not get stuck because we identified beforehand that D, we don't really have like a, okay, we can find if you need, but the D is problematic here. So let's try to avoid D. That was the spirit here. Okay. Now let's do a second, like a question number 4. So let's say the sum of the first 5 terms, S5 of a sequence is 100, and the sum of the first 6 numbers of that same sequence is 1 to 23. Okay, so it's about talking about the same sequence. So find the nth term. Sorry, find the 6th term. Okay, so here now you can always apply this, you know, so you can find that A5 is, see, A5 yeah, I mean, yeah, you don't even need to find that term. This is fairly straightforward because this is asking about, now if you look at these 6 numbers that they're talking about, okay, if you take them as A, B, C, D, E, F, means that these 5, the sum is 100, okay, and these 6, the sum is 123. So therefore, F, or the 6th term, should be 123 minus 100, right? That should be 23. So straightforward. No need to apply the equations here. So as long as you know the theory behind it, there's very little need to apply equations. Okay. Now let's do question 5. So in a sequence, the sum of first n odd integers is n squared. So I'm asking you, what's the sum of this arithmetic sequence starting with 13, 15, 17, 39? Okay. So I'm sure you can find this in a straightforward but like a long, lengthy way. For example, you can find now what's the sum of all first odd numbers up to 39, and then see this is an odd number sequence starting with 13. So you can find the sum of odd numbers up to 39 minus the sum of odd numbers up to 11. So this is the answer that they are asking for. However, there are different ways of getting there, right? Yeah. So why do you think they have given this? The sum of first n odd integers is n squared. Okay. So the sum of odd numbers up to 39 means the 39 is the which odd number in that sequence. Okay, starting with 1, 2, 2 is not an odd number, sorry, 1. So if you look at it this way, 1, 3, 5, 7, 9. So 9 is the fifth odd number. And then 11, 13, 15, 17, 19. This is the 10th odd number. So similarly, 39 is the 20th odd number. And 11 is the 6th odd number. Okay. In order to get this one, the sum of odd numbers up to 39 is n squared, which is 20 squared. Okay, n is 20 in this case. Whereas here, n is 6 minus 6 squared. So that will be 400 minus 36. That will be 364. Got it? You can always put other equations here, okay? So for example, if you want to put, now this is a sequence itself. You don't have to consider what's before that and what's after that. So this sequence, okay, you know that A1 is 13, AN is 39. Okay. So from here to here, so the sum is A1 plus AN, n over 2. So as long as we know n, we can find the sum. because we know A1 and we know AN as well. So A1 is 13, AN is 39. So how do you find N? You also know that AN is A1 plus N minus 1D. Okay, so we know that AN is 39, A1 is 13 plus N minus 1D is 2, because these are odd numbers. So by solving this, 26 is equal to N minus 1 that times 2, N minus 1 is 13, and N is 14. Okay, so once you apply that here, you get Sn is equal to 13 plus 39, which is 52, times 14 over 2. That's 7. So 52 times 7 is 350 plus 14, which is 364 again. Okay, so the idea is that they give you an equation like this because there's something in it, okay? Something that makes your life easier. So just be mindful and try to get that. Yeah, and if you follow that sort of logic, this is very easy actually. Okay, the last thing that we are going to do here, the sum of, so I will say that the sum of 5 consecutive integers okay is equal to 205. So I'm asking you, what's the sum of the next 5 integers? You want to try this? So this is actually, if you write in terms of n plus 1, right? Because these are consecutive integers. Okay, and that's 205. So you get that 5n plus 10 is 205. From here, n is 39. Okay. So the sum of next 5 integers is n plus 5 plus n plus 6 plus n plus 7 plus n plus 9. Okay, n plus 8 is missing. That would be 5n plus, this is 11, 18, 26, 35. Okay, that's the sum of the next 5 integers. So n is 39, 5 times 39 plus 35. So that would be 195 plus 235. So that's 230. Okay, so that's about sequences. Just follow the next video that I'm going to post, and that will contain sets and grids and permutations and combinations. Pretty much the same thing that Gayara and Nakalanka taught you, with a few, different examples. Yeah. I'll see you in the next video.